Okay folks, so we solve logarithmic equations a couple of ways. First way is to rearrange it so that the log is by itself and then convert it to an index equation. So here's an example. You have to bring that power of 4 down to the front over here. So you get 4 log to the base 3 of x equals negative 16. And then hopefully you can see that you can divide by 4 to get rid of that 4 first. That gives you log to the base 3 of x equals negative 16 over 4, which is negative 4. Then we take this point and convert it back to an index equation, so that becomes the base over here and kicks the negative 4 upwards. So you have x equals 3 to the power of negative 4, and 3 to the power of negative 4 is 1 on 3 to the power of 4, which is 1 on 81. There you go. So this is the other kind of logarithmic equations where there's lots of logs on both sides, and you need to write one log term on each side of the equality, and then you have to equate the logs. So here's an example: log to the base e of x and log to the base e of x minus 3 equals log to the base e of 4. So you've got 3 logs with the same base. So you can use the multiplicative index law first up to combine these two into a single log. You leave the right hand side alone, and then you can see hopefully that these have the same base, so that means we can actually equate the arguments. X bracket x minus 3 equals 4. Now you have a quadratic, you just have to expand this out. X squared minus 3x, and then you have to, let's draw that out. Then you make everything equal 0, and then you factorize, and away you go. This factorizes very nicely to x minus 4x plus 1. And what do we do next? Then your two solutions are x equals 4 and x equals negative 1. However, we can't have that case because our logs are only defined if whatever's in the brackets or the arguments are positive. Okay?